Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty interesting problem that we're very excited about, so let's go ahead and read the problem statement. Alright, so it says the question is called path sum 2, right? It says given the root of a binary tree, right, and integer target sum, return all root to leaf path where each path sum, right, equals target sum. Alright, so a leaf, right, is a node with no children, right? Alright, it's a good thing that they let us know what a leaf node is, right? What they consider a leaf node. So a leaf node, guys, no children, node with no children, right? So we could easily see them, right? So this one is no children, right? So that's a leaf node, leaf node, leaf node, leaf node, right? Because they have no children, right? Also 13 is a leaf node because it has no children, I'm saying. Yeah. So 8 and 4, they're not leaf nodes because, they have children, I'm saying. They have both a left and right child. So they're not leaf nodes, I'm saying. So 7, 2, 13, 5, and 1, those are leaf nodes, right? So yeah, so what they want us to do, guys, I'm saying, can be which is very, very good. They want us to pretty much, they're going to give us like a binary tree, right, and a target sum, right, and our goal, right, is to find paths, right, that has starting from the root to a leaf node, right, that has a sum, right, when you add all the numbers along that path, right, when you get to leaf node, right, that equals to the target sum, I'm saying. So that's a very good thing to keep in mind. So we did a problem similar to this, guys, a while back. So it was called path sum, right? But that question asked us to pretty much see if there exists a path, right, in the tree that has a sum, right, from the root to a leaf node, right? When you have a sum of target sum, what I'm saying. Yes, we only need to find if it exists, what I'm saying. So we return true or false, right? If there exists a path, one path, what I'm saying, not two, one path. That's all we need. But this question, right, wants us to find all the paths that has a sum of target sum. I'm saying when you add all the numbers along that path, starting from the root to the leaf, right? So if you guys haven't seen that problem, I highly suggest you guys go check it out because it's gonna give you a lot more context when you do this problem, right? It's gonna, yeah. So yeah, guys, so pretty much we're going to solve it the same way we solved it the last problem. So pretty much we're going to have a current sum variable, right? Pretty much to keep track of our running sum, guys, I'm saying, as we revisit the nodes, right? So this is a classic depth first search problem, I'm saying. Depth first search is more intuitive to solve this problem with, I'm saying. Probably ways to solve a breadth first search, I'm sure I've seen solutions on that. But intuitively, when I saw this problem, the easiest way was to do a depth first search. So that's what we're going to use, right? So we used that last time to solve it, so we're going to use the same algorithm, guys, to solve it, right? Pretty much the constraints just change, right? They want to find all the paths, right? So guys, how we're going to go about it, right? We're going to have a current sum variable, right, as we visit the nodes, right? So right now the current sum will be 5, right? And then we visit this guy, at the current sum will be 9, right? Visit this guy, current sum will be 20, right? Visit this guy, current sum is 22. So we get to a leaf node, we check, does that sum equal to that, right? We add it to it, right? We would visit 7 first, right? But it would be 27, and 27 wouldn't equal. So that's why. But we would visit 7 first, right? And then we visit 2. What I'm saying, and then yeah, we see that we get to a leaf node, right? It equals that, so we add it to the output. All right. So now this one, right? So now how are we gonna keep track of the numbers that we've seen, right? Okay, the current sum, pretty much keeps track of the current sum for that number. So how do we know the numbers that belong in that path, right? That's why we're gonna have a temporary list, right? That's gonna help us in populating, of keeping track of all the nodes that belonged for a particular path, right? And then yeah, so that's why we got a temporary list, guys. I'm saying. So let's go through a quick example real quick. I'm saying. So yeah, I think it's gonna be it's gonna make a lot more sense to you guys. So right now, guys, I told you guys we're gonna have a current sum variable, right? And we're gonna have a temporary list, right? That's gonna keep track of all the nodes that we're accounting for, right? Because as we visit the nodes, I'm saying. So we add that temporary, and then the res, right? Pretty much that's our output list. So I'm saying that's output list. That's gonna have all the paths, right? Pretty much a res is pretty much a list of lists. I'm saying, yeah, that's what res is, represents. I'm saying that's what's gonna hold all the paths. I'm saying. So yeah, guys. So now let's say we add 5, right? We add 5. We add 5, right, to our running sum. So 5 gets added, right? And we also add 5 to the temporary list, right? We do that, guys, because we're simply that we're accounting for it right now. I'm saying, so it's in there. I'm saying we add it to the current sum, right? We add it to the same, right? And then now we visit the left child first, right? Because we're gonna do that. We visit the left, right? And then we get to 4, and once we're at 4 now, we update the current sum variable. Now current sum variable is 9, right? And then we also added to the temporal list that we're building, right? And then now the next thing that we do, guys, I'm saying we visit this guy. I'm saying 11. Once we get to 11, 11 plus 9 is 20. What I'm saying. So now we add 11 to it since we're accounting for it now, right? So now we're gonna visit all of 11's children, right? So once we're at 11, right? We go to 7, all right? So we do 20 plus 7, 27, right? Once we get to 7, right? And then we add 7 to it, right? And then we check, is 7 a leaf node, right? Yes, 7 is indeed a leaf node. So we check the current sum, right? Does it equal the target sum that we're looking for, right? Which is 22, right? No, it does not. So we end up returning from the, we're like, all right, cool. We don't add it to the output list. So I'm saying since this path is not a good path, right? So we don't account for it. So now we visit the left and right child, right, of 7. There's nothing there. We return, and then now there's nothing to do, right? So now we go back up the recursive call. We go back to 11, right? So now since we're going back up, right, we need to remove 7, right? Since we're not accounting for it anymore. You know what I'm saying? So now we're back at this level, right? And at this level, guys, at this level, right, 20. So the current sum, the running sum, right, is 20. You know what I'm saying. So now we're back up here, right? So now we go visit 2, right? 2 is the next child that needs to get visited, right? So now once we get to 2, right, the current sum updates to 22, and then we go there as well, right? Now we see 2, right? We add 2 to the output list, right? Since we're accounting for 2 now, and then we see, right? Does 22 equal 22? Yes, it does, right? Since it does, right? We add that list, right, to the output list. What I'm saying. So now that's why we have this right here, right? So now we're going to be going through the stuff a lot faster now since we know how to do it now, right? So we get that path, right? So now we visit all of 2's children, right? There's no children, so we remove. So now we're done processing 2, right? Everything for 2. So now we're going to go back up to 11. I'm saying. So now we remove 2 from the thing, right? And then now I told you guys we're at this level at 11, right? The current sum's 20, right? And then now we're at 11. So we process all the nodes at for 11, right? So now we go back up the recursive calls. I'm saying. So now we're not counting for 11 anymore. So we're at 4 now, right? And then the sum as well gets decremented. I'm saying, since we're at 4 now, at this level 4, and now we go right. There's nothing there, right? So now we're gonna go back up to 5. I'm saying. So now we're not counting for 4 anymore. We remove 4. I'm saying. Yeah. So it gets removed, right? And then we're at 5 right now. 5 has more nodes on the right, so it's still in the list, right? So now from 5, right, we go to 8. I'm saying. So now we're counting for 8, right? I'm saying. So yeah, remember when we go back up to 5, right? We also decrement the current sum, right, is 5 at this level. I'm saying. So now when we go visit 8, since we added 8, right, we need to account for it. So now we do 5 plus 8, 13, right? And we're 13, and then boom, and we go here as well, right? And then we see 13 plus 13, right? It's 26. I'm saying. We also need to add 13, right? So we saw that 13 is a leaf node, right? We check, does 13 equal to 20? Does 26 equal to 22? No, it does not, right? So it has no term, right? We go back up the recursive calls. We remove 13 from the thing, right? And then we go back up. So now at this level, we're at 8, right? We're at 8 now because we done process all the nodes for 13. We're at 8 now. Now we go to this guy, to 4, right? So now we do 13 plus 4, which gives you 17, right? And then now we also need to account for 4. 4 is in the list, right? We add it to 4, right? Yeah, and then we're at 4, and then 4 is going to visit all of your children, right? So we go to, so we're at 17 now. Then we do 17 plus 5, right? Gives you 22. And then we also need to add 5 to account for it. I'm saying this is what represents all the nodes, right? That's in that path. What I'm saying, and then this is what all the nodes when you add all of them up, right? This is what their sum, right? So we see that, right? We see, all right, 22 equals 22. Now that's a good path, so we're good. So now since 5 is a leaf node, right? We do that check, right? It's a leaf node. And the current sum equals to 22, the running sum, right? So now we're like, cool, that's a good path, right? So now we add it to the output list. I'm saying, yeah, guys. Yeah, hopefully you guys were able to follow. Yeah, so this is how we're solving it. I'm saying this is the algorithm. I'm saying, so hopefully you guys will follow and understand my thought process, how we're gonna go about solving this problem, guys. I'm saying, and then there's no other path that has that, and then we know how you go back over the recursive call. So yeah, all right, guys. So right now, what we're gonna do, right? We're gonna have a list, right? A list of lists, right? So this is what's gonna hold our. So what's gonna hold our result, right? Or output. I'm saying, and then we're gonna have this helper function, guys. I'm saying, which is gonna help us in doing our DFS, what I'm saying, our depth first search on the tree, what I'm saying. So we're gonna pass in the root, right? We're gonna pass in the output, right? Then we're also gonna have to pass in the target sum, right? And then also we're gonna pass in 0 to help us in keeping track of our running sum, right? As we go visit the nodes, right? So after we visit all the nodes, right, we do that for search, right, and when we come back, we should return res, right, because res is the output list, right? It's gonna have a result, so that's why we return that. I'm saying. All right, guys. So let's go ahead with the with our function, right? So we do void, right, because we're not gonna be returning anything. So unlike the other one, right, when we were returning true, it was a, I'm saying, it was a boolean value, so boolean return. So we're not returning anything, so we're good on that. Yeah, so now I told you guys we're gonna have a tree node root, right? And we're also gonna have that output list that we talked about, and then we have our target sum, right? And then we have the current sum, right? Current sum to help us and keeping track of our running sum as we visit the nodes, right? Just clarifying that. And then guys, if the root is null, we know simple base case, right? Root is null, we return, right? And then guys, what we do next, right? It's gonna be very important. So as we visit the nodes, guys, I told you guys, right? We keep adding the nodes values, right? Okay, so we add that value to the current sum, right? And then the next thing that we also have to do, right? We should see this right now. We've been doing the same thing as the other problem, right? So now an extra thing that we need to do, right? We need a temporary list, right, to hold our values, right, as we visit. I'm saying, because that we want to keep track of that, because once we get to a leaf node, right, we want to add that temporary list that we're building, right? That's that's gonna help us keep track of the numbers that belong in that path, right? We put that in there, and then once we get to a leaf node, in that leaf node, all this current sum, right, equals that target sum. We would add it to the output. I'm saying, so that's why we also need to keep track of that side. So we create an empty list, right? So now integer CMP, right? So that's gonna help us in adding all of our. Since we just added that number to the running sum, right? We also need to add it to our temporary list. I'm saying, to account for. We're accounting for it now. I'm saying. So now we do a check right here, guys. Which is very, very good. All right. Sorry. All right. We do another check, guys. I'm saying the check is gonna be root to that left, right? Equals to null, and root that right equals to null, right? I told you guys, right? That's what's gonna allow us to know if we get to a leaf node, right? Okay, so we got to a leaf node right now. The next check that we do, guys, I'm saying, which is very, very important, we check if the current sum, right, equals to the target sum, right, that we're looking for, right? So we got to a leaf node and we see the running sum, right, leading up to that leaf node. Does it equal to that target sum, right? If it does, guys, I'm saying that means we have found a good path. I'm saying, so where's that add array list, right? We do that, guys, because we're doing a deep copy. I'm saying and I add the temporary list, right, that has all the numbers that belong in that path. What I'm saying, and I do a deep copy of that when I add it to the output list. What I'm saying, that's how you do a deep copy, because I could have easily done that add CMP, right? That wouldn't be good, guys, because they're passed by reference, right? So when I go in my other recursive calls, right, all the numbers that belong in that old path, right, are still gonna be in there. You know what I'm saying, there's the whole reason why I make a deep copy of that, so that we don't, since the object is being passed by reference, so to account for that, right? So once we found out, we got to a leaf node, right, and then you see the current sum equals to target sum, right? The next thing that we end up doing, if that's not true, right, let's say we don't get to a leaf node, right, we need to recursively, right, check our left and right child. I'm saying, so we add res, right, and then the target sum, right, and then the current sum, right, and then our temporary list. I'm saying, and then now we do another one, right, which is root that right. See the right child now. I'm saying, passing res, we're passing the target sum, we're passing the current sum. All right, so okay, and then after that, guys, I'm saying the next thing that we need to take into account, and the next thing we need to account, right, we need to remove the the node at the level that we are right now, right? Because now we've done exploring, we finished exploring, right, all the nodes, right? So now we're gonna go back up the recursive call. So I'm saying, so we need to remove that node to simulate that we're not accounting for it anymore. I'm saying, right? Yeah, just like, you know, if we're done exploring, right? So let's say we're at 2, right? So now we're done. We went to went left, 2 went right. They both returned null, and then now we said, all right, cool. Now we don't need 2 anymore. We're not at this level anymore. Right? So we remove it. I'm saying we remove 2 from the temporary list that we have, right? And then we're good. That's why we do that, since we're going back up. So now since we're done exploring 2, we would go back up to 11. So that's why we need to remove the 2 guys. I'm saying. And then just like when we did exploring all the nodes for at node 11, right? When we going back up the recursive call, right? We're gonna go back to 4. We remove that guy. I'm saying to say that to no, we're not accounting for it anymore. So it doesn't need to be in the temporary thing, right? I'm saying. So yeah, guys. I think we're pretty good shape right now. So let's try to click run. Let me see. Goes to null. All right. Click run right now. All right, that's good. Let's click on submit. Perfect, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this video, and I'll see you guys in the next one.